Hello, my name is Sobhan Patnaik. I'm a senior PhD candidate here at the University of South Carolina. I'm majoring in nuclear engineering. Been here for 3 years. My work is based on fracture studies of advanced nuclear fuels under high temperature accident situations. Every day there's a new development, new kind of thing coming in, and when I come into the lab, either I'm told, like somebody tells me, hey, I have a test running, do you mind taking a look at it, give me some results, give me some updates, or I have somebody who I can also tell, hey, can you help me out with my stuff? So it's very casual, it's very friendly, and it's very fun to be in the lab, basically. Most of our work is related to the Department of Energy. That's where we get our funding from mostly. And every result or every research that's been done here, they are a part of some DOE projects or initiatives. So that way you feel that, okay, you're sort of making a difference. When you talk to people from the industry or from different schools and everything, you don't realize that you are contributing in a big way until they tell you, oh wow, oh, you're doing such kind of research. That's awesome. My work, I came on board because there is this is a DOE's initiative to restart a transient test reactor, which is based in Idaho Falls in Idaho as a part of Idaho National Lab. That's the TREAT, or short form TREAT. That was decommissioned in 1994, so the US DOE and NRC, they wanted to get it back online. And for that, they made a proposal saying that we have a group of universities and INL came together saying, okay, we're going to restart the TREAT reactor. So for that, you force a nuclear fuel to extreme conditions. You ramp the power up, you cool it down super fast. You basically push the fuel to its limits to see, can it survive that kind of temperature changes? Can it survive the accident scenarios? If yes, what happens to it? If not, why didn't it work out? So my job here is to do something called as out-of-pile testing of nuclear fuels. So basically, in a nuclear fuel rod, the fuel pellets are in pile, like they stack on top of one another, making a fuel rod. So basically here what I'm doing, I have single nuclear fuel pellets, and I build a vacuum chamber where I put the pellet in there, I ramp up the temperature real high, I cool it down super fast, and I capture the temperature gradients and cracks. So based on those results, I give them to the Idaho National Lab and they basically create models based on my experimental results for the TREAT reactor. And to see how the fracture of fuel is related to temperature changes, if there is any physical property change like expansion, stress concentrations, release of efficient gas, there's more. So that's how I fit in. So I do the experimental work and provide the results for them to validate. All nuclear fuel-related research currently in the US are towards safety first. Definitely, that's a big concern. So here we don't want that we reach a certain point in the reactor that it's already under an accident is about to happen and we could not predict the temperature or the kind of fracture we expect, so that if we know that, we definitely can save it or protect the fuel from undergoing such kind of fracture or accident. So basically, yeah, safety first, and that leads to efficiency and everything else follows. I never really thought that the work that I do for my degree would matter to people in general. So when you realize that you are doing something which will be eventually taken at a national lab, and they're gonna make, so your results would impact the validation of some models, which would impact the working of a reactor. So that, if you think about it, it's wonderful.